In 11.6, we are going to be solving trigonometric equations. And when we do this, we're going to do this on a certain interval. If I tell you something where the interval is in degrees, I would like your answer in degrees. If I give you something where it's specifically in radians, I would like your answer in radians. When we're solving, we're not so reliant, even though we could use trigonometric identities like we did in 11.3. Instead, we're going to rely on our algebra skills in order to solve the equation. And then once we have that equation solved, then we would use our inverse trig in order to actually find the answer on the given interval. With that being said, we're going to start off solving part A. Now in part A, we have 3 tangent theta equals tangent theta plus 2. I just want you to treat tangent theta like x. Treat it like a variable. I want to solve for that variable. I want to solve for tangent. So it's basically like saying 3x equals x plus 2. And solve it using algebra. Well, I'm going to subtract tangent theta from each side. 3 tangent theta minus 1 tangent theta is 2 tangent theta equals 2. Tangent theta is still not by itself, so I need to divide by 2. So using algebra, I got it down to tangent theta equals 1. Now I just want to know what theta is on this interval. So I would use inverse trig. So that way that cancels, and I'm just left with theta equals tangent inverse of 1. So me personally, probably just because I'm used to it, I can visualize my unit circle. Now it says, we know that the unit circle is from 0 to 360 degrees. We want theta to be between negative 90, which is right here, and 90 degrees. So we're just looking at this right-hand side, or quadrants 1 and 4, in the unit circle. Now I want to know, when is tangent 1? Well, that would either be here or here. And the reason why I say that is because angles with 45-degree reference angles could get a tangent of 1, since the coordinates are root 2 over 2, root 2 over 2. So this coordinate right here is root 2 over 2, root 2 over 2. This coordinate here, however, is root 2 over 2, negative root 2 over 2. So will one of these, none of these, or both give me a positive 1? Well, just this one right here would give me a positive 1, whereas this would have given me a negative. So that one doesn't work. So theta would equal, and you have to write your answer in degrees. So this was a 45-degree angle. If you're not able to rationalize it using special right triangles, you're welcome to use the copy of the unit circle I'm going to give you in class. So you would just look and see, because we know this is negative 90, this is 90. You'd look to see which special angles would give you 1. However, I think you're going to have an easier assignment if you remember your unit circle and you freshen up on that a bit. So part B, let's go ahead and solve for cosine theta. So the first thing to do to get it by itself is I should subtract the square root of 3 before you divide by 2. Okay? So that would leave me with 2 cosine theta equals negative root 3. Now I can divide by the 2. Cosine theta equals negative root 3 over 2. And then to get theta by itself, I use inverse trig. And remember, inverse trig is basically saying what theta value would have a cosine of negative root 3 over 2. Remember, cosine is the x, and I want a negative root 3 over 2. If I rationalize that, I'm like, okay, well, cosine being x, that would be quadrants 2 and 3. So I know that my angle is going to be somewhere here. And it says I'm wanting between 0 and 2 pi, so full rotation. I already narrowed it down to quadrants 2 and 3. When would cosine be a negative root 3 over 2? So in my mind, I know that's when I have a 30-degree reference angle, so I can immediately just put that. Or you could look at your unit circle. We can see here I have a negative root 3 over 2, negative root 3 over 2, and that's at these angle measurements here. Now, the interval was in radians, so I want to write my answer in radians. That'd be 5 pi over 6, 7 pi over 6. Let's try the next one. For part C, it says, find all solutions for the trig equation. So what we want to do is, let's solve it like we normally do, but the way we write theta is going to look a little bit different. Let's solve for sine first. When I see this, I want to get the sine over to one side. I'm going to move the 1/2 sine over to this side because I like to keep it positive, if I can. So 1 minus 1/2 is 1/2 sine theta. To get sine theta by itself, I'm going to divide by 1/2, or you could have seen that as multiplying by 2. Either way, we're going to end up with the same answer. So this would use keep, change, flip. So that's 1/4 times 2 over 1, or 2/4, or 1/2. So to solve for theta, I need to take inverse sine. So what I'm asking is, for what theta will have a sine value of 1/2? Well, if I think about my unit circle, I'll draw it right here. In my unit circle, positive sine values will be in quadrants 1 and 2, because that's where we go up, above the x-axis. 1/2 for the y value would be at my reference angles of 30 degrees, so I can visualize that it's going to be right here. Or you could use your unit circle. You see a positive 1/2 here, a positive 1/2 here in the y position. Now, the values, and I'm going to write it on my paper, is 30 degrees, which is pi over 6. And then right here is 150 degrees, which is also 5 pi over 6. Now, I didn't specify radians or degrees. I just said find all solutions. So these are solutions in our typical 0 to 2 pi, but for all solutions, it would be these and all of its coterminal angles, which should sound familiar because when we found positive and negative coterminal angles in degrees, we would add or subtract 360. For positive and negative coterminal angles in radians, we would add or subtract 2 pi. So what I would do here is I would say theta equals, let's do it in degrees first. Either 30 degrees or it could be 150 degrees. We would then write plus 360n. By adding 360, we would get the coterminal angles, and times n means I can multiply it by any integer, and I'd get a coterminal angle. So that gives me all of the solutions, both positive and negative, because I could multiply by a negative number. If I wanted to do it in radians, and it's really up to you, whatever you want to do, we could do radians, which is pi over 6 and 5 pi over 6. Just remember, instead of adding or subtracting 360, for radians, we would add or subtract 2 pi, which is equivalent to 360. So we would add 2 pi n for this rule. I probably will write it in degrees, but on the answer keys, I'll write them in both just in case you have a preference. Part D. We have sine squared theta minus 2 sine squared theta equals 3. So whenever you see something squared, like just imagine this as x squared minus 2x equals 3. I told you before, when we have a quadratic function, try to set it equal to 0 first. So I'm going to try to get this set equal to 0. In order to do that, I'd subtract 3 from each side. So that gives me sine squared theta minus 2 sine theta minus 3 equals 0. Again, think of this as x squared minus 2x minus 3. Set equal to 0. You could do the quadratic formula. You could complete the square. The easiest thing, though, would be for it to factor. So we're going to try and factor this. This is a trinomial where the a value is 1. So remember, we just ask ourselves what multiplies to give us this term, but adds to give it this term. And again, we're treating sine theta like x. So I will put sine theta here, sine theta here. What multiplies to give me 3 is 1 and 3, but adds to give me negative 2 using different signs would be a positive 1 and a negative 3. I'm solving this equation though, so I'm going to set each binomial equal to 0. So again, what I'm doing here is I'm using my algebra skills from Algebra 1 and Algebra 2 to try and solve for theta. Now think about your unit circle. Does sine ever equal 3? No, it doesn't. So that's not going to give me any solutions. However, does sine ever equal negative 1? Well, yes, it does. Think about the unit circle. Sine is a positive 1 here or a negative 1 at 270 degrees or 3 pi over 2. Taking a look at my interval, I see it's in radians, so I would say theta equals inverse sine of negative 1. So theta is 3 pi over 2. Part E, same thing. I want you to set it equal to 0, and then we're going to try and factor it. So I need to subtract 3 from each side. This is a trinomial where a is 1, so I'm going to treat cosine like x. What multiplies to 3 but adds to give me a positive 2 using different signs would be minus 1 plus 3. Set each binomial equal to 0 and solve. You should recognize that cosine of theta is never a negative 3 on the unit circle, so that won't give us a solution. But cosine is a positive 1 here at 0 to pi, or 0 degrees, 360 degrees. Because it's in radians, I know my final answer should be 0 and 2 pi. Now, because I'm running out of time, I'm going to talk about f. It was being squared, so I had to move the sign over, set it equal to 0. I noticed that it wasn't factorable unless I pulled out a GCF. So sine theta equal to 0, and I set what's in parentheses equal to 0 and solved. Pause the video and check and see how I got my answers.